Hello friends, we are going to continue the problems in curve setting. Till now, till the last video we have completed up to setting out a curve by cards produced. Up to that we have completed the median methods. The last one is the angular method. In that Rankines derivation we have already seen. In that we are going to continue the problem. After that we are going to discuss about the vertical curves and the problems related. So in this video we try to complete the first half of the fifth unit, right? So this is the problem. We start. Two tangents intersect at chain edge 1190 meter, the deflection angle being 36 degree. Calculate all the necessary data for setting out a curve with a radius of 300 meter by deflection angle method. The peg interval is 30 meter. They have given us 30 meter, right? So the basic components you have to determine: tangent length, length of the curve. You know the formula. You substitute all the values. You get the values, and you try to obtain the chain edges, right? Whether they have given chain edge at intersect. So point at intersect they have given. We need to determine chain edge at T1 and T2, right? So chain edge at T1 and T2 can be determined. The diagram, all the given data we have marked here. Subtract the tangent length. You will obtain the 1190 minus 97.48. You will get the chain edge at point of tangency T1, 1092.52. If you add the length of the curve, you will obtain the chain edge at T2, right? So you will get 1281.02. Now we need to fix the chord such a way that we are able to determine the deflection angle of each chords. At what angle we have to set the chords, right? That distance we have to fix. The length of the first subchord and the last subchord will be minimum. You try to, since they have given the 30 meter, so subchords must be less than 30 and it should not be too small also, right? So the length of the first subchord, if you consider, say it starts with 1092.52, they have round, you may round to 1100. It is nearly 7 point something, 7.48 meter. You can have it, but at the end of the thing you will cross over 30 meter and the last subchord will be resulting 1.0 meter, so which is very small. To avoid that we go extra 10 meter. So the subchord is 17.48 meter and the last subchord, the end is 1281.02. so if you add 30 from 1110, 30 is 40, 70 to 1200, 1230, 1260, 1290. It is not possible, so 1260 is the last before chord. The remaining is 21.02 meter, right? So the from that you can obtain the number of normal chord as 5 meters. Total length of the curve is 188.50. In that, two subchords we have already fixed. So if you subtract and the chord interval is 30, you will get the 5 normal chords plus 2 subchords, totally 7 chords. So the deflection angle for each chord we have to determine. The formula you know, 1718.9 into Cn by R. For first subchord you have to substitute the 17.48, last subchord 21.02, remaining all are 30. Whatever the calculation you obtain in minutes, try to convert to degree, minutes, seconds, right? So similarly, remaining normal chords, first one is remaining one, del 2 to del 6 is based on 30. It is 2 degree, 51 minutes, 53 seconds, and last one 21.02 with a subchord, you will obtain 2 degree 0. So for first del, this del 1 is equal to small del 1, this del 2 So del 2 is del 1 plus del 2, you will obtain. Del 3 is del 1, del 2, del 3. Similarly, you can obtain all the del. At last, total angle is 80 degree, which must be the check of half the deflection angle of the curve. The deflection angle of the curve is 36 by 2. So hence the check is okay. So based on the angle, we can set the curve. So here the accuracy we can maintain very high compared to any other linear methods. Right? I hope you understood the Rankines method, friends. Now we shift to the vertical curves. So types of vertical curves, depending upon the different combination of different grades, the following 6 types of vertical curves are generally met while executing a rail or highway project. Mainly these will applicable in railway and highway. So here the grade decides the curve, right? An upgrade is G1 plus upgrade followed by a downgrade, right? So now how to make the curve? This curve has to be made, and this point is in virtual top of the air. This curve has to be set up based on the distance, right? Another one opposite to that, a downgrade followed by upgrade, right? It is contrast to this first type. The third one is an upgrade followed by another variant upgrade, right? So this is also possible. And next to fourth type is an upgrade followed by another upgrade in different manner. See, compared to this way, here also it is upgrade but little bit down, but it is also upgrade. Similarly, the contrast will come, the downgrade followed by another downgrade followed by another downgrade. Here the G2 is greater than G1. The G2 is greater than G1. The numeral value percentage grade is, right? So the length of a vertical curve, how we can obtain it? The length of a vertical curve may be defined as the length from the point of commencement of the curve, that is the point of rising to the point of tangency of the curve, that is the point where curve meets horizontal straight again. Let L1 be the length of the curve from the point of commencement to the summit, that is G1 grade, be the upgrade, and R be the rate of change of grade. So then the formula is the L1 is equal to percentage of upgrade, that is G1, divided by rate of change of that particular grade R. Similarly, the length of the curve from summit to the point of tangency. So percentage of downgrade by rate of change of grade. So G2 by R, the L2. This is the general formula you have to follow. In consolidation, the total length of the curve is G1 by R plus G2 by R. As upgrades are treated positive and downgrades are negative, equation may be written as upgrade G1 is positive, minus of minus, it becomes positive. So hence the length of the vertical curve may be obtained by dividing the algebraic difference of the grade by the rate of change of grade with due regard to the sign of each grade. And note, these 2 points are important. In general practice, nearest full number of chains is adapted and half of the length is set out to either side of the summit or valley in the case of railways. In case of highways, the calculated length of the vertical summit curve is also checked for side distance as described. Generally I have given a small note based on that. Right, now we will see with the example problems. Calculate the length of a vertical curve if an upgrade G1 is equal to 1.4% is followed by a downgrade G2 is equal to 0.6%, and the rate of change of grade is recommended as 0.1% per 20 meter chain. The formula we have is L is equal to G1 minus G2 by R. Here G1 is 1.4%, it is upgrade positive. G2 is downgrade minus 0.6%, and rate of change they have given us per 20 meter change, it is 0.1. So if you substitute all the values, you will get 20 chains. One chain is 20 meter. We obtain 400 meter is the length of the vertical curve. Similarly, calculate the length of the vertical curve if an upgrade G1 is equal to 2% is followed by another upgrade 1.5%. Assume the recommended rate of change of grade as 0.1 per 30 meter chain. Same formula. We substitute both are positive. Here the negative will be retained, which is equal to 5 chains. They are given 30 meter chain, so 5 into 30 you will get 150 meter, right? There are many detailed workout is available in vertical curves, but it is out of scope of our syllabus, right? Thank you friends, I hope you understand.